Good job clicking on this video. We're looking at OBS Studio, which is an extremely popular way for streamers to stream their stuff. It's written mainly in C and some C++ and some Objective-C and some Objective-C++, which I forgot was a thing. I think that because I expect this is going to be a pretty big project, I think what I want to do is focus maybe more on the architecture. How is it designed? How is it laid out? Rather than the implementation details. What I will do, though, is I will open up tests. libobs is presumably going to be the central point. Deps might be important. I think that probably the way that it's laid out is it delegates a lot of the hard work to well-known multi-platform libraries such as FFmpeg. So that's one reason I think that deps might be important. OpenGL, D3D11, don't really know what that is. It vaguely rings a bell, but I don't know. And then we have UI and CI. UI is, I assume, user interface. CI is probably continuous integration. Let's look at the CI, I guess. We have freebsd.sh, the FreeBSD full build script. So I guess maybe they use FreeBSD as their testing platform. And then we have some includes, and then these just like shell scripts, install dependencies, build OBS, and package OBS. Maybe they also use this for packaging. And these are just shell scripts. I assume they're just basically calling make somewhere. CMake? Okay, so it's some CMake build. UI, a lot of OBS is going to be about the UI. So I assume that this is a good place to be. We have lots of auth stuff. I'm going to guess that this is for authenticating to the streaming services. So if you're using OBS, for example, to stream to Twitch or to YouTube, then you need to authenticate to those to Twitch or YouTube, as the case may be. So there looks like there's lots of good stuff in UI. All of it looks like it's C++. Here's libobs D3D11. Let's check out what D3D11 is about. Direct 3D 11 graphics. That's what I thought it might be. So let's ignore Direct 3D, partially because I don't know much about Windows and partially because I don't care much Windows. This folder is going to be some sort of GL integration. This is, I guess, where we get a lot of the C as opposed to C++. Wayland. Let's look at Wayland EGL just for fun, just to take a quick peek, the quickest of peeks. This is just, I guess, making some function available. And then we're defining some static consts. And we have some implementations. Things like extension supported. And what are we doing? We're checking I guess we have some list of extensions and we have some search term, and we're just checking if that extension if the thing we're searching for is something that we support, I suppose. All right, I think that the OpenGL folder is probably not essential. I think the Windows, this is UI, so that is important. Deps, let's see what we have. We have Blake 2, which is maybe the hash algorithm. File updater, GLAD, which I think is maybe a GTK toolkit potentially. Happy eyeballs. Some JSON stuff, libcaption, perhaps caption support, OBS scripting, opt parser is, I suppose, most likely going to parse command line arguments. So I don't see like an FFmpeg folder here, which is fine. Blake 2, let's verify that that's just the hash algorithm. Yeah, cryptographic hash function. GLAD library, a loader generator, based on the official specs of what? Of what? Why use Glad Library for OpenGL initialization? So maybe it's some OpenGL initializer thing. Maybe GL, AD, maybe it's a pun. Maybe it's a pun on GL. Happy eyeballs.age. Of RFC 6555, Happy Eyeballs to connect to IPv6 hosts with IPv4 fallback. Why is it called eyeballs? Okay. I don't know why it has eyeballs in it. I don't know what the IPv6 versus v4 has to do with eyeballs, but that's fine. Okay, so that's mostly stuff we can ignore. All I'm doing right now is verifying that as I look at the code, I'm not missing more important code. So if I'm going to, spend my time, focusing on one thing, I'd like to know that that thing is what I should really be focusing on. So just ruling out some other stuff is really all I'm doing. I thought I had opened tests. Maybe I got too greedy in closing things. Oh, what is this? What? No, not that. Okay, so libobs does perhaps look important. We have audio monitoring, callback, data, which might just be static data, graphics, media IO, and some stuff like AVC and AVI look codec related. We have encoder and decoder and some FFmpeg stuff. So maybe I'll pop this off into their own thing. And then test, test is broken down by like OS to some extent. We have Windows and OS X have their own test folder. And then we have CMaka, which might be a mocking thing. We have array basic test. And that's tiny. Let's look up CMaka. Yeah, okay, so unit testing for C. Fine. That's fine. And then test input. We have a few tests. Probably fewer tests than I would really want for something like OBS, something as complicated as OBS. OBS, I feel like it's not super buggy, but it also doesn't seem super stable. So probably more tests would be good. If you like OBS and you want to contribute, that might be a good thing to add. And so I think that where that leaves us is the UI and the libobs. Let's poke around the UI a bit first. OAuth. So this is just going to be OAuth authentication. I won't dig into it. Maybe I'll look at auth base quickly. We have audio encoders, the header, and the implementation file. They're right next to each other, which is the style I prefer, as opposed to having headers in their own folder. We have API interface, which might be important or interesting, and some XDG stuff. This is like the desktop file. We don't care about that. Update. So here's where maybe some of the crypto stuff is, perhaps pulling signed images off of some package repo. And I guess Windows and Mac seem to have updaters. I don't know if Linux has an updater. And are forms interesting? Some auto config stuff. We have OSP basic.ui and advanced audio UI. Let's look at these. How about basic filters too? So this is presumably some format that describes declaratively what the user interface is supposed to look like. And what is source toolbar? Some toolbar UI, it looks like. Then we also have fonts and images. Should we look at one of the images? How about mute.svg? So this is just what the mute button is. That icon has to be somewhere, and this is where it is in particular. All right. And then we have things like front-end plugins. Can I close this GitHub window? I'm going to guess this is support for plugins. Let's maybe open it and take a look. The front end API might be interesting. And then I think really all we opened up was auth. So let's look at a few other things at least. We have FFmpeg utils. I guess let's look at the header there. Horizontal scroll area. A lot of this looks just like things that maybe almost could be in any UI toolkit, as opposed to one particularly devoted to what OBS is devoted to. Media controls, I guess let's look. Media slider, multi-view, I'm not sure. OBF, I don't know what that is, but we'll take a look at the header at least. And there's some manifest that might be kind of like the manifest of UI elements, I'm not sure. Platform is presumably going to be some sort of entry point for customizing for Windows versus OS X versus Linux. Qt display is presumably what I'm using on Linux. I guess they must use Qt. Record button has its own thing. Let's look at the record button implementation as well, I guess. And then a scene tree, probably fun. Maybe a screenshot. Source tree, source label, spinbox, UI validation. Let's look at the UI validation header at least. Scroll area stuff, window. This might be window as in the sense of a UI window as opposed to Windows, the OS. I'm not sure that any of these windows is particularly calling out to me. Maybe basic stats. I like stats. Window doc. Window main. Window permissions. And maybe window YouTube. And YouTube API wrappers, since those are things I happen to use. Now, we've opened up so many files that we're not going to really dig into all of them. As I said at the beginning, I'd like to really get a feel for the architecture more than anything. So what I'm looking for as I'm going through these files is going to be more about what design decisions did they make rather than like, what is this for loop doing or whatever. Here's auth base. And we are going to extend QObject, which I assume just comes from Qt. Pretty sure we can verify that. QObject class. Yeah. Okay. So this is it uses the Qt or Qt. Okay. So auth is some object. In particular, it's a Q object. So it's some UI object as opposed to, maybe there's more auth stuff in the guts, or maybe it's just all coded at the UI level. We have these save internal versus and load internal. So perhaps this is saving the authentication data, like saving your password. We have some variable about whether this is, I guess, the first time we load and some error information. And we have an enum that is asking us what kind of auth we're doing. We're using a stream key, which is where on Twitch or YouTube you basically get a secret, and anyone who has that secret is able to stream to your stream, or a linked account, which is like you have password-based login, and that gives maybe certainly YouTube, probably also Twitch, more of an ability to use their standard like anti bad guy mechanisms to try to prevent bad logins or whatever, as opposed to stream key, which is maybe more like just a bearer token. And then I guess we have like configurations for what the service is. And like all this looks reasonable. So I'm just going to move along. Here's audio encoders.hpp, but the UI version of audio encoders. We have like just basically containers. And we can get the bit rate map. I'm not sure why we need a map from ints to strings. I'm not sure what that means. Maybe this is like somehow the bit rates are parameterized by int. So maybe as you select them, this is the thing that as you like scroll through maybe some list of options, this is the thing that maps like maybe what that option is to something like what its implementation is. And you can get an encoder for that bitrate. You can find the closest available, simple AAC bitrate, etc. Let's actually look at this CPP file just to see what sort of thing it's doing. Handle list property. So here's populate simple AAC bitrate map. We've got a list of encoders like FFmpeg AAC, libfdk AAC, or core audio AAC. And the fallback encoder is encoders at 0, which because we see the implementation here is FFmpeg. And we've got this audio info thing, which is abbreviated AOI, but at least we get the fully named type so that we know what sort of thing it is. I've been reading a lot of code where people use like these little abbreviations where the you have to be in the know to know to even be able to find where that abbreviation is defined. But here they're nice enough to think about the readability here. And then we're going to iterate over the we're going to get the fallback bit rates. And where did they come from? I guess we called populate bitrate list here. Maybe that populated the fallback ones. And then for all of the fallback bit rates, we're going to set the in the bitrate map, we're going to set it to the fallback encoder. So it is setting a bitrate. It is mapping an implementation to a bitrate, like I was suspecting. And the way that it maps that implementation is it just has a string saying which encoder you're using. All right, that's basically all I wanted to know. This is just the file I just closed. API interface. So this is the implementation. I don't know if I skipped a header. No, I did not. Okay, so I guess the API interface just has the CPP file. And we've got some external volatile stuff like streaming active, recording active. I guess this is like, is the red button glowing? Are you recording or not? We've got this type of a callback. And the API interface thing has the ability to get a callback IDX. ID, I assume, X. I don't know what the X is for. And it's templated, I guess, by the callback function of T, probably the return type of the callback. And we have you get the callback IDX, you pass it in this vector of callbacks and a particular callback. And I guess you're going to get back some private data, some void star stuff, or not, and then you're gonna get a size T back. If callback, we're gonna iterate, and if the callback we're looking at currently is equal to the callback you passed in, then and the private data in the callback is equal to the private data. So this is not an out parameter like I thought it might be. This is something you pass in that I guess is maybe encoding like arguments to the callback or something like that. And at any rate, we're going to return I, which is the index. So I guess IDX is the index as opposed to an identifier for the callback. All right, and here's the OBS Studio API. We have front-end callbacks, I guess, such as main callbacks, save callbacks, and preload callbacks. So these look like hooks, essentially. Things to do when you save, things to do for loading. And we can do things like get the main window, get the main window handle, which just calls like winID on the window, it looks like. You can get the system tray, which is, I guess, just the icon, the data in the icon, as opposed to the whole system tray. You can get scenes, I'm going to guess, from the scene graph. So we're going to loop over, in main, we're going to get the UI and then get the scenes. Just loop over all of them, I guess, and assemble them somehow, grabbing a reference to them in some way. And then given the scene reference, we're calling scene get source on the scene and getting an OBS source type and checking if it's the null pointer. And if it's not the null pointer, we're going to push back onto the sources, the source we're looking at. And I guess when you call get sources, so I get scenes, you are intending to populate this thing essentially is both an in and an out parameter. You're going to get it filled up for you when you get it back, it looks like. You can also get current scene, and so on. Get transition duration. I don't know what transition duration is, but it takes no arguments. So I guess there can only be one transition duration. This is maybe a transition between scenes. What else can we do? We can get scene collections, the T-bar position. I don't know what the T-bar is, but it's some UI element, I guess. And so on and so forth. Getting profiles, lots of getters and setters. Front-end recording start. Seems like it actually kicks off the recording. It does this queue meta object, which seems to be a cute thing, and it invokes the method on main start recording. So this looks a little bit like some kind of almost like an RPC system. Let's look at how Qt describes invoke method. Invokes the member a signal or slot name on the object. Okay, so signals and slots, I believe, is basically just like things like subscriber messaging. And so basically it is RPC or IPC. It's just sending a message to call a function or a method. To find if recording is active, we have this OS atomic load bool. So I guess there's we're going to atomically figure out if recording is active. And we can pause and I guess stop the replay buffer. It would be nice if I could maybe just can I do this? Yeah, I guess I can look for things that are called invoke method. Can I slide this? I guess not. I don't know what's going on with GitHub. Their UI is almost usable, but I feel like not quite. All right. At any rate, we have a bunch of methods, and we could see what they all were if this were cooperating. But that's the API interface. That gives me a good sense of what they're up to. Let's look at OBS Basic. This is the .ui file, and this is some XML file. And I think if you've done Android, they at least used to. I think maybe they still do. Their UI is encoded in XML files. That's also how Qt does it, if I remember correctly, and this seems to be a Qt one, so that's consistent. And what do we have? We have things like what the geometry is, the height and width, maybe of the main window, and we can set some minimum size, so you can like shrink it down to 0. And we have things like dock options and layout and all this stuff, and you should be able to Qt UI editor. You should have there should be some point and click interface whereby you can assemble these UIs. I don't know if this is one of them, but something like this. I guess their UI has lots of clocks, and then this thing should somehow correspond to XML. Okay, so here's more audio stuff, and maybe if we had one of those programs, we would be able to like load up this UI file and see what it looks like, but I don't have one. Now that I know what these are, I'm just going to close all the UI stuff. And here's front-end plugins. And these are maybe like just default plugins that are included. And I don't know what they are. I think I'm mostly going to skip them. Here's the front end API folder, which has the header and a bunch of events. So we have events like the kind of events you would suspect, like recording started, recording stopped. The scene has changed, things that you would reasonably expect a lot of plugins or UIs or programmatic ways of controlling OBS to be interested in. Replay buffer started. Event studio mode enabled. I forget what studio mode does, but we have this T-bar thing. We find out the T-bar, OBS T-bar. Toolbar. But which toolbar? Aren't there like a billion toolbars? Is it this thing? Okay. We have stuff about the scene collection, like whether it was renamed, has profile. Is the profile changing? This seems like the change might be in progress. The event theme has changed. And we get some stuff like freeing. This seems to be like maybe deallocating objects. And we have a note. Wait, what is swig? Swig. I vaguely recall simple wrapper and interface generator. Okay. Written in C++ with scripting language such as blah, 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 blah. So maybe this is scripting support. What if I do OBS swig? Getting started with OBS scripting. Nearly all wrapper functions are generated automatically by Swig during OBS build, based on the API function definition in C, for a few complex C functions and structures. Blah, 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 blah. So what language is it? Lua? I think I saw Lua. Can be extended with Python and Lua scripts. Okay, so I guess maybe Swig supports Python and Lua. And this is some generation stuff for Swig. We have a note here. Functions that return car star star string lists are a single allocation of memory with pointers to itself, free with single call to be free on the base car star star pointer. User interface should not use typical Qt locale transition methods, as the OBS UI bypasses it to use a custom translation implementation. Okay, so they have their own translation implementation. I'm not sure why. Perhaps performance related. Perhaps the Qt one sucks for some reason. I have no idea. And this all looks like maybe this is stuff for consuming essentially via Swig, perhaps. Here's FFmpeg utils, but in the UI folder. So kind of like UI related utils, presumably. We have some codec enum, whether it's audio, video, or unknown. Some string equality method, looks like. A format, an FFmpeg format, which includes things like MIME type, name, long name, audio codec, etc. And things like whether it has audio or video, I guess, in the format. And then we have a FFmpeg codec, I guess just essentially some custom wrapper, I assume, that is designed to be nice to use by the OBS people wrapping whatever FFmpeg is doing. Here's mediacontrols.hpp. So we have some SIGs. I'm going to guess OBS signal is maybe an extension of the Qt signals. We have a weak source. I don't know what a weak source is. Maybe a weak reference to some source. A few timers, including a media timer and seek timer. Seek and last seek, I guess these are seek maybe in the sense of rewind and fast forward. Whether prev is paused, I don't know if previously paused or preview is paused, a countdown timer, and whether we are in slideshow mode, which I think is maybe like full screen. And we have a bunch of methods, like static methods, like whether media has stopped, whether, hang on. This is called OBS media stopped. It doesn't return a bool. You give it some data and maybe some like call data, maybe arguments to some function. But play sounds like a command. It's in the what's the word? Imperative. It's in the imperative mood. But play and pause are imperative, but stopped and started are in the past tense. So I don't know whether these are supposed to be things that act or things that are essentially give you information about the state. But we also have some slots, like on, play, pause button clicked. So this should be Qt support for listening to OBS events. Now I don't know if this is if the events we saw before are the same as these Qt events, or if there's like if that's a different layer. But that seems to be what's going on here. Then we have things like media slider. So all of this seems pretty Qt oriented, which is cool. I think Qt is a good library. But I'm going to like plow past it and see if we can see some kind of more under the hood stuff. Maybe let's take a look at scene tree. This should be a scene tree. And I think that compared to something like Blender, which we've looked at before, I imagine the scenes in most OBS setups are much smaller than the Blender ones. So for Blender, it's expected that you might have in some cases a server farm for rendering your scene. For OBS, it's expected that anywhere in the country or around the world, a streamer with an ordinary laptop or computer can stream. So I imagine that the typical and not only that, but streaming is like real time, as opposed to like rendering, which is something you can do asynchronously. So this scene tree should be smaller than some of the scene trees we've seen before, and so maybe we won't go too deep into it, but we'll take a quick gander. We have some grid in a grid mode, and we can control the height of the grid. And then we have this explicit scene tree, which just has a parent. You pass it in the parent. But where is it defined? We have event filters, resize, event. I'm not sure what an event filter is, but maybe it watches for specific events. Start drag is presumably what happens if you start dragging the scene, or maybe the grid that holds the scenes. And things like whether the selection has changed. Scenes reordered. This is, I guess, some signal that says that those scenes have been reordered, so that if you're indexing into the list of scenes, then you know to change your indexing scheme or whatever. So this scene tree here, I guess this is the class scene tree. So I guess this is just the constructor. Where else is parent? All right, well, whatever. And I think I opened up the CPP file. Look at that. So when you pass in a parent, we're going to call install event filter this. So installing some event filter, set the drag and drop mode to interval move. I guess maybe you have to move by some interval. And we'll set the movement to QList snap. And we reset the parent. And then we can set the grid mode. And this is just setting stuff and whatnot. Okay. So that it doesn't seem like much of a tree. But we have parents. But if everyone only has one parent, I guess parent was a pointer, right? So I guess you might have a list of parents. Is it? No. I don't know. I'll move along though. Screenshot. I'm curious how they do screenshots in a platform independent way, but maybe Qt takes care of that. We have GS text render, stage surf, GS. That's a graphics thing, right? That's different from GL. Now we have some Q image. Let's look at the implementation. We don't have that open yet. CPP. Not found. Screenshot obj. So maybe this is just the obj, and there's, I don't know. There should be some implementation. Oh, okay, I see. So the window basic main screenshot.op is maybe screenshot tick. We have this add tick callback, OBS enter graphics, stage surf destroy, GS text render destroy, OBS leave graphics. So enter and leave graphics, I guess, is marking out a critical section, or yeah. And then what, I don't know what a screenshot tick is. Maybe that's some timer. And then we do this some threading. I don't know what we imported for threads. But somewhere we get threads. Where's th? If th, this seems to be the first reference to th, right? Okay, somehow we know about what I assume are threads. If cx and cy, what are they? I don't know. Possibly x and y coordinates, maybe coordinate x and coordinate y are non-zero. Then we get the OBS main window, show some stuff in the status bar that the screenshot was saved to something. We set the last screenshot to path, which is I guess, the place where we saved the screenshot. I'm not sure where that path came from. And we do this, essentially call all the things that are wanting to know about screenshots being taken. And this seems to be the screenshot function. Or yeah, is this called up here? Oh, is this a destructor? Yeah, okay. I don't know what I was doing to read that. All right, so screenshot function, or rather, yeah. So we'll get a strong reference from the weak reference. And if it's non-null, then we'll get the cx and cy are the width and height. And otherwise, we, I guess, get the width and height from the video OVI video info. And if we don't have X and Y, then we bail out. Then in Win32, we might check some color space stuff. And we might do some tone mapping. And more color space stuff, which I will ignore. And we do some stuff here, like video render. And I'm going to guess that maybe that's essentially where we get the screenshot. And we call GS blend state pop. Yeah. So let's take a look at GS. Is this part of OpenGL? Graphics enumerations. So we're on the OBS website. So GS stage texture copies texture to a staging surface and copies it to RAM. Ideally best to give this a frame to prevent stalling. So I'm not sure what GS is, but it seems to be possibly OBS specific. All right, so I'll ignore UI validation and some of this other Windows stuff, including the YouTube stuff. And let's hop into the libOBS, which I suspect is where some of this stuff is defined. In fact, what we can do is grab, I still have this in my, yeah, so let's look in live grep. So GS stage texture is, let's call it in a bunch of places. And maybe this looks like the documentation. Here's maybe the function in graphics/graphics.c. I'll try browsing in live grep. Can I click on stuff? I guess I can't really. I notice if I click, then stuff changes up here. I can view on GitHub. That's kind of useful. All right, let's try that. GS stage texture. So you give it a stage surf, some stage surface, presumably, which is a DST, maybe destination. You give it a texture, which is, I guess, the source. And we get the graphics thread or a pointer to it and check that that is valid. And if it is valid, we call on the graphics thread this exports dot device stage texture, passing in the graphics device and the destination and the source. All right. Well, I don't know what these functions do, but presumably it's this text, some sort of texture staging stuff, or applies texture to a stage. Here's GS begin frame. Again, we get the graphics thread, and on graphics we call exports device begin frame on the graphics device. So a lot of this code is basically it seems like the only value maybe it's adding is that we're unifying that that this is in the being called in this particular thread perhaps, and having some check, and then we're just immediately delegating to the same function that is in exports. Not the same function in the sense that every it's not that every, I'm not saying that every function calls the same function on exports. I'm saying there seems to be a one-to-one mapping between what graphics exports functions are doing and what functions in this GS file are doing. So given the one-to-one mapping, it's not entirely clear what the value add is there. And maybe it's just that things are checked or things are nicely organized. Up here, we get some sort of implementation that looks more, much more in depth. For example, cube texture create. You give it a size and some color info and some levels and some a list of datas, I guess, and flags. And then again, we get the thread graphics. Check if the size is a power of 2. Check some stuff about building MIP maps. Check for validity. If it's using MIP maps and it's not a power of 2, then we emit a warning saying that we're disabling MIP maps. I guess MIP maps need a power of 2. And if we are using MIP maps and we've set the GS render target flag, then we might emit a warning. Otherwise, we delegate to the graphics export thing again. So maybe this stuff that looked like implementation is really just more validation. Let's look at the graphics header in that case. And let's go back to where I was. Is the header here? Must be in graphics. Graphics.h. Copyright 2023. I was just curious when it started. I think OBS is much older than 2023, but this is maybe this file's from 2023, or maybe they just update the copyright headers every year. So this is an API, independent graphics subsystem wrapper. It allows the use of OpenGL and different direct read versions through one shared interface. So that makes sense. On the other hand, it seems like there should be a bunch of these wrappers that are available. So I don't know anything about, I've never programmed graphics myself, so I don't know about when it makes sense to use something off the shelf versus when it makes sense to wrap everything in your own custom way. And we have some enums like draw modes, points, lines, line strip, etc. And continuing that thought, maybe the way that like a game engine needs to extend or wrap graphics libraries is more in depth and involved than the way that something like OBS needs to. And so maybe one of the virtues of doing it yourself is that it's easier for OBS maybe to have something that's simpler, lessens the attack surface and the surface, the ability of things to blow up or whatever. So being able to tailor the wrapper to your use case is maybe one of the virtues. All right, we have some enums for color formats. Z stencil format. I don't know what a Z stencil is. Maybe some stencil in the Z direction. I don't know. But what are some of the examples? Z16, Z32F. Let's look at the Z32F. I don't know. Not a Nissan Z. Call mode, I guess call as in maybe like remove from the back or the front or neither. How are we blending, etc. Okay, so that's graphics.h. And the idea there is to wrap things. We have also effects, device exports, bounds, base math. I expect some of this will look similar to some of the stuff we've seen in gaming systems. We have, I guess, an implementation of 3D and 4D matrices, 4D presumably for quaternions, 3D presumably for 3D rigid motions. We have a model of the plane. We have quat, which sounds probably quaternion, and 4D, 2D, and 3D vectors. This is another thing. I would imagine there's a bunch of implementations of this stuff, but I've also seen several times each like game engine implement their own. So I don't know how to think about why that's the case. If you know, let me know. Here's effect.h. And we have this enum called effect section, param technique sampler pass annotation. I'm not sure. Maybe there's like an encoder versus decoder pass sampler. Maybe the effect is sampling something. I'm not sure. And we have this GS effect param struct. Okay, so we have some shader parameters. We can init the parameters, I suppose, and we can free them. We have pass shader params, which is maybe the shader params that we're passing to something else. We have an effect pass. And I'm not really sure what all this is doing, but it seems to be related to shaders and getting shaders maybe onto the GPU and keeping track of what stage we're in as we're doing the GPU stuff. So here's a struct for the GS effect. GS, for whatever reason, seems to be their prefix for graphics stuff in OBS. They have a bool for whether we're processing, a bool for whether things are cached, some paths, like I guess where is the effect, maybe on disk, and the directory. That's the fact that it says directory seems to suggest that it's like where on the file system. Some array of parameters and techniques. I don't know what a technique is. Current technique, and then current pass, and then the parameters like the world, the scale, and the view proj. I'm not sure if those are generic GPU stuff, like or if those are modeled in OBS, but presumably it's something to the effect of like the world is maybe all the scenes, kind of in generic coordinate space. View proj is maybe the viewport through a camera, essentially like a perspective on the world. And scale is, I'm going to guess, some sense of scale, but I don't know the details of like if we're scaling, maybe zooming in and out in the camera or something like that. I'm just kind of curious what a technique is, but maybe live grep again. Live grep just seems nicer and faster than GitHub search. Technique. Effect, get technique. Solid. Okay, so maybe solid is one technique. Solid color. Optimization technique. Is that it? Not sure. Effect technique. Techniques are used to define the primary vertex/pixel shader entry functions per pass. One technique can have multiple passes or a custom pass setup. These days, multiple passes aren't really needed. GPUs are powerful enough to where you can perform all actions in the same shader. Okay. So let's pull this out. Does it tell us like what some of the techniques are though? It doesn't really seem to. But I suppose that's okay. Here we go. Maybe technique draw. So it says technique draw and then it has some passes, but I don't know what other techniques there are. I guess it doesn't really matter that much. All right. Here's the Matrix 3 implementation. We're including Vec3 and whatever axis sang is. Axis ang, I guess axis angle. And why implement your own? I don't know. Maybe it's a generic. Maybe it's a generic interface over like 3D matrix implementations that come from the underlying graphics libraries like Direct3D. In fact, why don't we look at the implementation? Let's look at Matrix 4. No, it seems like we're just implementing them in here. Okay. So just different matrices. A plane is just going to be some model of the plane. This is going to be quaternions. Quaternion math, generally used to represent rotational data more than anything, allows for efficient and correct rotational interpolation without suffering from things like gimbal lock. Yeah, I'll ask ChatGPT, why does OBS use create its own 3D, 4D linear algebra and quaternion implementation instead of using a stock one? Customization and optimization, portability, licensing and legal considerations, lightweight and focus, historical reasons. It's been developed over time, and it may have evolved from simpler implementations. Okay, so I'll say, are there good fast implementations of these libraries that are commonly used these days? Eigen is a C++ template library for linear algebra. GLM is a header-only C++ thingy. Eigen 3, which seems like it's probably the same as Eigen, but a newer version. Bullet Physics, while primarily known as a physics engine, Bullet also includes efficient implementations like vector, matrix, and quaternion operations. So people use it, I guess, for stuff like physics and collision detection and rigid body dynamics. In the Intel Math Kernel Library, MKL, but I think MKL is mainly for Intel. I think it will run on other systems, but will run much more slowly than on Intel. Okay, so those are all plausible reasons why they have their own implementation. I guess there's a sense in which it doesn't really matter, but I guess like if you were, if you were contributing, it would be nice to know why are things done. Why is this particular design choice made, so that you can have some context. And so that's graphics. Audio, I think we're going to mostly ignore. Callback. Audio monitoring, at least. I don't know. Let's open it. And then there's a bunch of stuff like AVC. This is going to be, I assume, mostly calling out to things like the encoders. Support for Wayland. I guess let's look at Wayland. I feel like maybe it misbehaves under Wayland currently, or maybe the version I have does. But we can look at the headers and the C files for just OBS, and then I think we'll call it a day. Here's callback. This is just going to be some callback implementation. We have signals, which may be Qt signals, maybe other signals. Let's see if they're Qt signals. Signal handler. This is used to create a signal handler, which can broadcast events to one or more callbacks connected to a signal. We don't seem to import any Qt stuff. So we have signal handler T, which is, we have the signal handler struct. We've type diffing the signal handler T thing. Signal handler add array. You give it a signal handler type and some signal decals, which is a car star star. We'll set success to true. I guess it's a defeasible assumption. If we don't have signal decals, we'll set it to false. And while we have signal decals, we'll try to add it to the handler. And I guess handler returns bool or something if it fails. If it fails for any handler, we will say that we failed. Otherwise, we'll say success. So we're basically just adding something to a list. And then we have connect, disconnect. So this seems to be their own signal implementation. And then I guess we have things like decal, maybe for declarations, proc for processes, perhaps. Procedure handler. No, procedures. It's used to allow access to one or more procedures that can be added or called without having direct access to declarations or procedure callbacks. Cool. All right. Here's audio monitoring. And we're broken down by system, OS X, and Win32, or are Apple and Windows respectively. Pulse is presumably Pulse Audio, which is certainly what's used for Linux. I don't know if Pulse Audio also supports other systems as well. But this is going to be some Pulse Audio support, which is interesting. I'm not going to look at it too carefully. Here's OBS AVC. Helpers for parsing AVC NAL units. We have things like keyframe, et cetera, et cetera. Do they implement their own parsing stuff? I guess that file doesn't exist. I guess GitHub is tired of me and is rate limiting me. So I'll move along and maybe come back to that. Here's OBS encoder header. And we have some defines like whether things are deprecated. We have a struct for an encoder packet, which includes things like the data, the packet size, some timestamps for, I guess, when it was presented versus when it was decoded. And maybe you can use that to determine how long it took to decode. And then a time-based numerator and denominator. Maybe that's for translating between different timescales, like minutes versus seconds or microseconds. Not sure. Then we have an encoder type, which is this custom enum, and a Boolean about whether it's a keyframe. And we have this encoder frame thing, data for the frame, audio, size of each plane. I don't know what an AV plane is. And then we have some regions of interest. Which has things like priority and also like the rectangle coordinates, top, bottom, left, and right. I don't know what region of interest is used to do, but it's there. So encoder interface, encoders have limited usage with OBS. You're not generally supposed to implement every encoder out there. Generally, these are limited or specific encoders for H.264/AAC for streaming and recording. It doesn't have to be just H.264 or AAC, of course, but generally those are the expected encoders. That being said, other encoders will be kept in mind for future use. So this is some like info struct that gives you kind of metadata about the encoder you're implementing. And you can do things like create the encoder, you can destroy it, and you can call encode. And when you call encode, you pass it some data and an encoder frame and an encoder packet, and whether you receive the packet. Set the true if a packet was received, false otherwise. Okay. So this looks like a generic encoder implementation. This is cool, I think, in its own right. If you wanted to learn about encoding and decoding, this is probably a pretty good project to dig into their generic interface for it. It's probably not going to be as generic as something like FFmpeg that I assume tries to support everything in the world, or maybe VLC. But the lack of genericness, genericity is a benefit, I think, when you're trying to learn something, and this code seems especially nice and clean. So this is probably a good place to learn if you want to do audio and visual stuff. OBS internal.h. I don't know what this is going to be. I'm mostly speeding along now. We have some validity checks to check, I guess, whether some object is valid, which just checks the pointer and debugs and returns false if it's a null pointer, I suppose. We have OBS module, which maybe it's a module system. We have a module name, a file, a binary and data path, a pointer to the module, whether it's loaded. So this is some module system maybe for plugins. And then we could free the module, check the path. We have hotkeys, which have an identifier, name, and a description. The function to execute. Some data, which can be anything. Pressed. I'm not sure if this int is like the keyboard code or something else. A registerer type. I don't know what a registerer type is. Maybe who registered or how they registered. And there, I guess, a pair partner ID. Pair partner. No idea. It's in some handle. This is some sort of handle. And then a hotkey pair is maybe like key combinations, like Control F versus just F or something, or Control F12 instead of just F12. Okay. And then we have OBS display, which has things like color space, whether it's enabled, X and Y coordinates, next X and Y coordinates. That's kind of a strange model of it. I'm not sure what that means. We have X and Y, so we're in some 2D space, but we can only define a line. And then the next is maybe the next line. I don't know. Maybe they're defining a rectangle by alternate points. I'm not sure what's going on. And then we have next and previous next. So maybe next is just here to kind of optimize moving quickly through whatever space that they've modeled it as. All right, that's fine. They've got some texture stuff. That's all pretty interesting, but I'm going to move along. Why did I open up AVC? I don't remember. Well, I think I was going to see if there's an implementation, but maybe I won't. Wayland just has this Nix hotkeys vtable. Maybe Nix as in destroy? Or I don't think it means Nix as in the Nix package manager. And there's no CC file here. Was it Wayland? Oh, it's .c. That's why. So Nix hotkeys vtable will just return the hotkeys vtable. I don't know why it's called Nix. I'm not sure. Oh, maybe just Unix. I'm going to guess it's just Unix. All right, obs.h. The main libobs header used by applications. So I guess if you're an application, you're supposed to import this header, and this will give you access to stuff like the API. And we get some more enums used for changing the order of item. For example, filters in a source or items in a scene. More enums like whether to allow direct rendering, some stuff about what kind of scaling we're using. If you, I guess, scale up, you need to do some sort of interpolation. So blending methods, general graphic stuff. Here's a swig thing. This is presumably to enable things like Python and Lua. Source frame. So all of this stuff is, in addition to the API file, you probably want to look at this obs.h file if you're planning to make some sort of OBS client. Then obs-c is going to be largely, it looks like just kind of like setup code to make, like I think by the time you're in obs-c, all of the hard work has been done elsewhere, and you're mostly just figuring out what thing somebody's trying to do by calling the API, and then calling the correct function to do that. It is kind of what this code looks like, just glancing very quickly at it. And then obs.hpp has all this weak source, weak reference stuff. So maybe this is just modifying the OBS-C API for C++, making it nicer for C++. So that's OBS. I'll stop there. And in a couple of minutes, we will take a look at Ogre.